This is the last section in Chapter 9, and we're going to look at energy needed for a phase change. So you remember this diagram, and this shows you the energy, which is along the horizontal, that's required for a solid to change to a liquid to a gas. So we'll usually refer to water, but every substance undergoes these phase changes. Now the heat of fusion of water you defined the other day, and the heat of fusion in particular for water is 334 joules per 1 gram of water. So you might remember when we were studying this in Chapter 9 that a joule is an energy unit, and you need that much energy to melt 1 gram of water or to change 1 gram of liquid water to solid water. That energy would be released. So the heat of fusion of water is 334 joules per 1 gram of H2O. The same amount of energy is released when 1 gram of water changes from a liquid to a solid. So this is absorbed when a solid changes to a liquid, so I'll say absorbed when solid to liquid phase change occurs. And then I say the same amount of energy is released when 1 gram of water changes from a liquid to a solid. So this absorbs the energy, and we use a negative sign to show the energy released. That heat of fusion is occurring right here. So if it's melting, it's adding that 334 joules per gram of water, and if it's freezing, it's releasing 334 joules per gram of water. So if you think about making ice cubes, you put in liquid water in your freezer. The water's actually going to give out some heat energy, and your freezer is going to remove that from the actual freezer. Now, heat of vaporization. It's the amount of heat required to change a unit mass of a liquid to a gas without an increase in temperature. So heat of vaporization of water, if we talk about water in particular, look at the value of it, 2,257 joules per gram of water. This is absorbed when liquid water changes to a gas, and it's released when that water condenses from its vapor. So this, when it's released, it's releasing 2,257 joules per gram. Think of this when clouds form. This is a lot of energy per gram of water, and this is really the energy that drives storms. Because you have warmer air, it can hold more water, and so you have a lot of water vapor in the air. So our last slide is just to remind you of this cycle from a gas to a liquid to a solid. Remember your terms, condensation to freezing. If we add energy, we go from melting to evaporation. And then remember your terms, going straight from a solid to a gas and a gas to a solid. Notice your red is when heat is given out or released, and the blue is when heat is absorbed.